Hi, and welcome to this new video about semantic kernel. In this will be a brief video, and I will do some further explanation from the previous video just to have you understand a little bit better how semantic kernel is interacting with everything. To better understand the kind of interaction between your large language model and your plugin, let's make an example. I'm adding a throw new exception to wait temperature on the GPU to perform the operation. So actually, in my C# code, I'm throwing an exception, and that can happen. The plugin can encounter every kind of error, and this is an exception. It's fun because it's not a real exception. But let's see what happens if I'm calling everything with the auto-invoke kernel function. Okay, so as you see before, it is invoking my plugin a couple of times, and then it tells me the GPU temperature is still too high. So that's fantastic. So it means that in semantic kernel, we can actually have your large language model of choice, in this case, GPT-4o, invoke your code and analyze any exception that the code is throwing and trying to give you a solution. Okay, and that's absolutely fantastic. Now, let's complicate the example just to understand the interaction. I've added optional parameter called GPU power, where the power is 100%. So it's absolutely fictitious parameter. And I'm throwing now the exception only if the temperature is greater, its power is greater than 70%. Okay, so it's a simple change. Now I gotta run again my example. And when I say I want to extract audio from video file, it's running and it has this other exception. And it seems that GPU temperature is too high. At full power, let's try extracting the audio with reduced GPU power. How about we use 50% of the GPU power? So the idea is the large language model is able to analyze our exception, okay? So it is able to understand that the problem is this kind of problem, okay? So it tells me, hey, I got an exception. The exception tells me that we have too much power. So do you want to, how about we use 50% of the GPU power? So now if I have a chat model, I can continue this conversation and I can do this. But let's change a little bit the prompt. Now the example is very similar as before, but now I want to extract audio from video file with 60% power. So now I'm run everything, and the beautifulness, the beauty of this interaction is that the large language model is capable of analyzing my prompt, understanding the parameter that I have in my function. And so it can understand and pass power 60. So I have no the exception. Now I didn't change my code. I still have the very same code of the plugin, but now I changed the prompt. I want to extract audio from video file. Start with 90% power and automatically retry reducing power by 10% until successful. And now run against this agent. And as you can see, it tries 90, it tries 80, it tries 70, and now it works. So it's the very powerful way to interact with the large language model. So the large language model is capable of continuing invoking our plugin, analyzing the exception. And if the exception is the temperature is too high, it tries to reduce the power. And this logic was not written in code. This logic is written by the user by using natural language. And that's the power of semantic kernel and interaction between plugin and large language models, calling this an agent, smart agent. Do you want to have more fun? Let's check this prompt. I want to extract audio from video file. Start with 90% power, automatically retry reducing power by 10% until you have too high temperature. Each time you reduce power, create an IQ. Finally, tell me all the IQ created. It will start calling plugin with power 90, then 80, then 70, and 70 it's good and it result. And the output is the audio extraction was successful at 70% GPU power. Here are the IQs created. At 90 power, GPU heat does rise, power too strong for the task. Cooling winds, we seek. Heat still lingers on, power reduced, yet too high. Patience, we must find. So that's some fantastic way of interacting with the model, because it shows you that it seems you are talking to an intelligent being. And this is really much more similar to and really intelligent things that you are not writing in code, you are simply writing by standard English language. That's the power of semantic kernel in this kind of interaction with a large language model.